Excuse me, today we're going to talk about multiples. Multiples. So multiples are a fact that you can use a lot of times, and it will actually make fraction work a little easier, but it adds on an extra step. So we use this in a lot of ways. So what is a multiple? The fact about a multiple is multiples get larger. So they use the times tables. So they get larger. It's a key to remember because sometimes we get multiples and factors mixed up. So I'm going to use the times tables to figure them out. So, if I want to find common multiples, this is what I do. So if I would like a common multiple between 3 and 4, okay, so I make a list. I start with 3, let's write that down, and I start with 4. So start with the number. So I have to actually use 3 and 4 to start my list for multiples. So what are the multiples of 3? 3 plus 3 is 6. 3 more is 9, 12, 15, 18. So what did I do? I skip, counted by 3s. That's what I did. I skip counted by 3s. Okay, so what am I going to do over here? 4, 8, 12, 16, 20, 24. So now I want to focus on common. Which ones do they have in common? They have a 12 in common. If I kept going over here, I would say they have this one in common. So common multiples, so that's what this is. Common multiple is this one and this one. These are common multiples. So in the multiple family, that's what they have in common. Okay, so let's practice them. Let's try to find the least common multiple. Oh goodness, there my dog goes again. Come on. Least common. Oops, I got distracted by that barking there. Least common multiple. So what is it? Least means smallest. This means in both. Common, the ones they have in common. All right, so let's try 5 and maybe let's try 8. What's the least common multiple? What do they have in common? So I start with this. 5, 10, 15, 20, 25, 30, 35, 40. Let's come over here. Start with 8. 8, 16, 24. So why am I able to go so fast on these? Because I memorized my times tables. I know my facts. Math is a whole lot easier when you know your facts. I know there's lots of you watching this video that struggle to find your facts. You need to memorize them. Math becomes a lot easier when you do that. 40. Do I see one in common? Yes. So the least common multiple is 40. So let's do another example. Let's say I'm using the numbers 3 and 9. 3 and 9. So I'm trying to find the least common multiple. between them. So I'm going to list 3, 6, 9, 12, 15, 18. What about 9? 9, 18, 27, 36. So let's see what they have in common. I see 9 on their list. I see 18 on their list. But which one is the least common multiple? It is 9. So I have to do the first one. So why are we learning this? Why is this helpful? Let's talk about fractions. Let's apply this to fractions. Okay, let's apply this to fractions. Let's say I had these fractions. Let's say I had 2/3 and 5/6. Okay, we've been taught that we go times 6 because this matches our model. Correct? We get 12/18 and 15/18. There's nothing wrong with doing that way. It works every time, but we get larger numbers. Let's talk about how so let's use the LCM. Well, what is LCM? Another way of saying this is LCM. Let's use least common multiples to find the least common denominator. Okay, so let's try it again. Let's try 2/3 and let's try 5/6. So let's try to find using the least common denominator using the LCM. So that means I need to make a list using my denominators. So use denominators. Let's make a list with 3 and 6. 3, 6, 9, 12. Let's come over here. 6, 12, 18, 24. Well, I can see my pen's starting to run out. All right, so I would like you to circle the ones that they have in common. Which ones do they have in common? Yep, they got a 6 in common, and they have a 12 in common. But I'm trying to find the least. So I have to find the first one that they have in common. So I'm going to use 6. So 6 is going to be my new denominator. So what did I do? New denominator. I use this as my new denominator. What do I do to 6 to get over to 6? Times 1 times 1. I didn't have to do any work. This fraction didn't get any larger. If I use this, remember I'm trying to get common denominators. So what do I do to 3 to get over to 6? What did I cut it up into? Times 2 times 2. 2 times 2 is 4. So over here, while I had 12/18 and 15/18, down here, my equivalent fractions were just 4/6 and 5/6. They were much smaller numbers. They still represent the same size. This has more pieces. It's cut into more pieces. This one's cut into less pieces. So when I add this one, I get 9/6. When I add this one, I get 12 plus 15 is 27/18. They are both improper fractions, so both of them, I have to see how many times 18 goes into 27. So I get 1 and 9/18. This one, when I did, how many times 6 goes into 9? I got 1 and 3/6. So I did all this work. This whole time, my numbers are larger. This whole time, my numbers are a little smaller. What does 9/18 and 3/6 have in common? 9 is half of 18. 3 is half of 6. So both of these equal 1.5. So I can solve it 2 different ways and I get the same answer. But this one has smaller numbers that I have to deal with because I use this LCM. Okay, let's practice this again. So I use multiples to help me keep my fraction, my numbers I'm dealing with in fractions smaller, and I don't have to do as much simplifying. So let's talk about if I have 6 and 9. Let's try that one. 6 and 9. So let's say I have these fractions. Let's apply it to a problem. So if I have 1/6 plus 2/9. So normally I would have done times 9 times 9 times 6 times 6. And I would have gotten 9. 6 times 9 is 54. This one I would have gotten 12 54ths. Large numbers. Let's try it using this new method that we're talking about today, using LCM. So remember, I have to make multiples. They get larger. 6, 12, 18, 24, 30. 9, 18, 27. So remember, I'm finding the lowest one I have in common. I found them. That's my new denominator for both of them. So this time I automatically multiplied by the other. This time I have to figure out what to multiply by. What'd you do to 6 to get to 18? 1, 2, 3 times 3. What did I do down here? It was only the second one. So 9 times 2 equals 18. So let's talk about both of these. 9 plus 12 is 21. This way, 3 plus 7 is, 3 plus 4 is 7. I always keep my same denominator. So let's compare them. These should be equivalent to each other, but what did I do? Here I have to simplify, already simplified. So this is already simplified. This one I have to see what number goes into it. I know my facts for 21, but I don't know my facts for 54. So that's why that might be a little bit harder for you to figure out how to simplify. Well, since I know this is going to be my answer, I actually know that 3 goes into it. Okay. So we use multiples to make our fractions have smaller numbers to deal with. They still equal the same thing. These are still equal. They're equal to each other. They're equivalent, but they have smaller numbers. If this is confusing to you, this extra step, we'll keep practicing so you'll know this before the EOG. That's fine to continue using this one and have larger numbers. We just have more work to simplify. So you do want more work at the beginning or more work at the end when you simplify?